Okay, my name is Paul Anderson, and this is Gail Anderson, and welcome to our tutorial, Make Your Clients Richer, JavaFX and the NetBeans Platform. This is our website, and first thing we'll do is we'll tell you a little bit about ourselves here. Okay, who are we? Well, we're a training company, first and foremost here. We do training courses for government and private industry. And we specifically do training courses in programming languages, of course Java, and we do courses in beginning Java as well as advanced Java and advanced Java topics too. We also have courses on Java EE and web, and we also teach JavaFX. We also, Gail and I have also spent some time here at previous Java 1 conferences doing hands-on labs, which is a different format than what we're going to do today, because this is actually a tutorial. And so that means that instead of us preparing a lab that someone goes in on a computer and goes through some steps, which is what we've done previously, we're going to kind of conduct this more like what we do when we do training courses in companies. And that will be, we'll be teaching you some nice concepts here for how to use JavaFX and the NetBeans platform together to design a rich client application. And then we'll also take some time to teach you a little bit about how we did that, and then we'll have a big program that we'll be going through, a real program that you can see, and you can see how all this works. Okay, we're also Java authors. Gail and I have actually written 7 books, and the last few books that we've written have all been on Java. And the most recent one that we have written is Essential JavaFX. So we've been into JavaFX early on in the game here. And we did that when the JavaFX was a scripting language, because that's the way it was when it first came out. And of course, JavaFX has evolved now into a set of APIs that you can now add to any Java application, which makes it a lot more flexible. And it means that you can take your Java applications and even your Swing components, and you can add JavaFX effects to them. And that's what we're going to do today with the NetBeans platform. Besides doing training courses and books, I've also got a live lesson video that just came out this year. And if any of you guys are on Safari and are subscribers to that, you can find that. I did it on Java Reflection. And I noticed that, by the way, that the last book on Java Reflection was written almost 5 years ago. So I thought that it would be good to bring everybody up to speed on the latest parts of that API as well. And then what we're doing at the end of this year and next year is we're currently writing a book on the NetBeans platform, which we are going to be publishing next year. Okay, so let's get started. Here's our agenda. But before we do that, I'd like to ask everybody in the audience, how many people here are currently using the NetBeans platform? Okay, excellent. All right, good for you guys. You know, we weren't sure how many folks were going to be here. You know, there's a distinction now. For you folks that aren't using it, there's a big distinction between the IDE, the NetBeans IDE, and the NetBeans platform APIs. And what we're going to be doing is we're going to be showing you how to use JavaFX with the NetBeans platform APIs. And if you don't know about the NetBeans platform, then we'll tell you about it today, and we'll give you an overview, and we'll explain to you what's going on with the code. And if you do know the NetBeans platform, then you get to see some new things with JavaFX and how you can use JavaFX effectively in a NetBeans platform application. Okay, so the first thing we're going to do, and then I should ask you also, how many people here are using JavaFX or starting to learn it? Okay. Good. You should be doing that. You know, there's a lot of effort on Oracle's part right now to promote JavaFX and to show people that, you know, it's a better alternative to Swing, and we're not, you know, it's not about giving up your Swing code. It's about, you know, working with these things together and learning JavaFX, which gives you a much richer client application that you can do on the desktop. Okay, so that's great. So here's our agenda. The first thing we're going to do is we're going to bring up our application, which is the smartphone data application. We call this the SDA. And this was something that Gail and I put together to demonstrate to people how they could use the NetBeans platform window infrastructure to handle the window operations that you want for a sophisticated application, and then support that with both Swing and JavaFX together. So you're going to see all three of those working together in a real program, which we call the SDA, and I'm going to demo that in a couple of minutes. After we do that, we'll then go back to these slides and we'll talk about the NetBeans platform. We'll give everybody an overview of that doesn't know about it. And for those of you that do, this will be probably familiar to you. And then what we want to do, which will even be new for some of you NetBeans platform folks, is that we're going to show you how to, from scratch, build a NetBeans platform application and add JavaFX content to it. So we'll do that. Then after that, I want to get into JavaFX Integration and show you some of the things that we implemented in the SDA. And so we'll talk about observable lists, properties and bindings. We'll show you how to use Swing and JavaFX together. We'll then talk about the importance of FXML in JavaFX and why you want to design with it. And then we'll talk about how to embed JavaFX in top components, which is the basic window of a NetBeans platform app. And then the SDA, as you're going to see here in a minute, is going to make extensive use of JavaFX charts, okay, really cool looking charts, and we'll show you how that's all integrated. And then we'll wrap things up here with Q&A. Now,
all the code is
and then right, Gail just reminded me to tell you that there's a lot of, you'll be able to get the source code to the SDA along with some smaller demo examples that we'll be showing you, and all of this will be available on our website this afternoon, which the website's on the first slide there. So you guys will get all of the code, and we'll bring that all up this afternoon. Okay, so we've got this is going to be interesting to do 2 hours here. We'll see how everybody does in an hour, but we might get up and stretch our legs or something. I don't know. We'll see. Okay, so let's go to the SDA. That's what Gail's going to bring up right now. And what we have here is a NetBeans platform application where we have our main program coming up here, which is the sample table model. And let me tell you a little bit about what we did here. We went to the web and we found some publicly accessible data that represents sales as units sold in millions for companies from 2008 to 2011. And so we organized that into a table, and then we decided to use JavaFX charts to show people how to analyze that data. So let's have Gail click on the run icon right now and run this project, and we'll show you what it looks like.
Hang on.
Now, the first thing that you'll see when she runs this is a custom splash screen, which is actually going to be, there it is, one of the charts, because you can do custom splash screens very easily in the NetBeans platform. And this is what our SDA looks like. These are all JavaFX charts that you're seeing in all of these groups here. And then down at the bottom here, this is a Java JTable Swing component. Okay, so we have Swing component JTable down here in this window, and then we have JavaFX charts everywhere else that you see here. Okay. All right. So we'll begin by showing you going through some of these charts right here. The charts, of course, allow you to look at the data and view it and analyze it in different ways. So we've grouped the 9 JavaFX charts into these 3 groups that you see here. We'll start with the left group. So what you're seeing on the left here first is a horizontal bar chart. And then if Gail clicks on the second tab, you'll see a pie chart. In the middle group, we have several charts. We have a vertical bar chart. We have a stacked bar chart. We have a bubble chart, and finally we have a stacked area chart. And in the right group, over to the right, we have a line chart, a scatter chart, and an area chart. Okay, now before we start interacting with this application, let's show you guys what some of the window operations that the NetBeans platform provides. Because remember, the NetBeans platform is managing all of these windows for us. We didn't have to write any code to do that. The NetBeans platform is doing all these windows and managing them for us. Okay? All right, let's select the bubble chart. And what Gail's going to do is right-click on the tab there and select float. And what that does now is it detaches the bubble chart from the others. So Gail can move it around. She can resize it. She can maximize it. And then take it back to its original size. We're writing no code to do this. NetBeans Platform is taking care of all of these window operations that you're seeing here. Now we can easily put it back into the group by just docking it. And all these are windows, all these are NetBeans Platform window operations that make this very, very easy to do as a developer. By the way, you can also right-click on the bubble chart there and select float and dock, and you can do a whole group too and move it around just the way we showed you. Now in the SDA, the NetBeans Platform also allows you to put together a top-level menu bar. So as Gail scrolls through some of those there, you have complete control over some of these things that you want to do. Let's look at the window one right now. And what you can see now is a list of all the charts. So what you can do here is select a specific chart and view its window. You can also close a window and then reopen it again through the file menu just by its name. Again, all being done here by the NetBeans Platform APIs. Up on the above the charts is a toolbar too, and of course we added the one on the left there. That's going to be the save chart, which I'll talk about a little bit later. Okay, let's look at the organization of this application now as far as its project and files go. Okay. All right. So Gail's going to bring back the project here, and what you guys want to look at now is what's on the left, and Gail's going to expand that node for you. Okay, in the NetBeans Platform, it's all about modules. And the smartphone data app has modules representing each one of the 9 JavaFX charts. You see a chart utilities module, a core module, and there's the JavaFX runtime, which has to be part of this project. And then underneath that is the smartphone data API module. Now, getting a little more detail in this, the smartphone data API module manages the table data that's in the bottom window, that's the swing component. The core module is the one that contains the NetBeans Platform top component, and we have a top component for each one of the windows that you saw there, and that's displaying the swing JTable. And then the chart utilities module is containing the code to save charts to the file system, which I told you guys we'd talk about a little bit later. Okay, let's go up and expand the bar chart now. We'll go back to, we'll go up here. Gail's going to expand the source code for the bar chart, and we'll look at the source files that are there. Okay, what you see is the top component code. Remember, that's what's managing the window for us for each one of the charts. A controller that you'll see later on when we look at the code, and a very important FXML file for scene graph layout. And I'll have a lot more to tell you all about that later when we look and see how we can do our scene graph layouts for our components using FXML instead of creating components as objects and calling setters and getters to configure them. And I think you'll like the approach that we'll see there. This organization that we have here that you want to take a look at is good because it keeps the JavaFX and its declarative code separate from the NetBeans Platform window code. Makes it easier to manage and easier to maintain. The other reason we set it up this way was because it helps you identify areas of your code where thread safety is crucial. And this is important because, as you're going to see in a little while, Swing and JavaFX are executing in different threads. So you need to pay attention to that. We'll show you how that works a little bit later. The other chart modules are set up the same way with similar naming conventions for their top components and controller and so forth. Okay, let's interact with the chart now. Show you what we can do with it. So we'll go back to the SDA. Here it is. Okay, we mentioned already that down below in the bottom window here is a swing JTable. Okay? And all entries in this table are editable. So Gail's going to modify an entry in the table right now. And when she does that, the charts will all modify and change. They'll all update themselves. Okay? You notice that the pie chart, the bar chart, and the line chart that you all see here, they all updated themselves automatically, but so did the rest of the charts too. They're just not visible right now. This is all being done with JavaFX animation, and it allows components to update themselves automatically, and we'll show you how we did that a little bit later on in this talk today. The other thing that I don't know if you noticed or not, but if Gail takes the mouse and moves it up there on the y-axis, the y-axis actually recalibrated itself too when the bar rose by the animation. And once again, all of that is being taken care of by these JavaFX components. We're just specifying the binding that makes that happen, and it all takes care of itself. The other thing that's interesting is that all the pie wedges move too, even though we only changed one value. And if Gail clicks on the reload data button right now, all the charts and the table go back to its original data. Now let's show you some of the JavaFX effects in the SDA. So the first thing we'll do, and Gail's going to float this for you here, so let's look at the pie chart first. Okay? Okay, now you might have noticed there's a little drop-down list view up there. So what first thing we'll do, when Gail gets this bigger so we can see it. Yeah, there we go. We're just making it bigger. Yeah, the resolution is kind of weird on this thing, so we're just floating these things for you. Again, notice how easy it is to do that in the NetBeans platform. Okay, Gail's going to go up to the list view now and click on these years. Remember, we've got 2008 through 2012 here. So the pie chart automatically updates itself and shows us, what the percentages are for the companies. Let's go to 2009 right now, and then show you another JavaFX feature here. Gail's going to select a wedge right now. And what we do is we animate that wedge by moving it with a transition. And at the same time, it has a drop shadow around it. So, if you're talking to somebody about RIM or Nokia or whatever, you can emphasize the fact that that's what you're talking about. And did you notice that there's a percentage label up at the top there that says that, RIM's percent value in that pie chart is 21%. Now, if Gail clicks anywhere else out there in the background, watch the label, it fades away and the drop shadow disappears. And we're going to show you how we did all this. This is all JavaFX. Gives you a very nice looking user experience here. And now what we'll do is we'll go to the bar chart and show you some of the effects that we did there. Okay, so this is the bar chart representing the same data now, just in a different way. So if Gail clicks on one of the bars, what we do is we tell you what its value is. And notice that that's rotated there. And if Gail clicks on a bar, notice that the number is showing up in white for dark colored bars and darker for, here's another one that's light. And if she goes back to a lighter bar, like the green one the green one right there, then it'll be black. So, we're looking at what we have there to customize that and to be able to display it appropriately. The same thing is true with the horizontal bar chart too. Do you want to show that?
Yeah.
So here's the horizontal bar chart, and Gail's going to float it and make that one a little bit bigger too. And we have the same effects here too, right? If you click on a bar and a bar there, it's going to display the value. Only now it's horizontal, right? Now we did something interesting with the bubble chart. So let's go look at that one. Here it is. Okay, if you click on a bubble, we make it rotate. And we also print out the unit sales up at the top there. And Gail can click on another one too. And these are interesting JavaFX transition effects. In fact, the rotating bubble that you're seeing right now is done with a JavaFX scale transition. And if you go back to the pie chart, she'll have to move over there. If you go back to the pie chart and move a wedge right there, that's being done with a JavaFX translate transition. And finally, when she clicks out there in the background and the label fades out, that's being done with a JavaFX fade transition. Now, the way we did all that was we designed JavaFX custom binding objects. We're going to show you how we did that a little bit later in this talk. Okay, a couple other things to show you, and then we'll get into this. If you want to save a chart to a file, we put this into the system. You can select a chart, and then you can go up to the toolbar at the top where the save is, and if you click on that, you'll see a save file dialog appear, which will allow you to save the chart image to a file. And you can do the same thing by going up to the top menu bar there and use the File tab to do it as well. And then the other thing that we put in was the ability to print charts to your printer. So once again, Gail can go down and say, right-click on, say, the pie chart here and say that she wants to print that. So she can right-click on that tab.
Hang on. No, I can't do that way.
Oh, there you go.
I gotta dock it.
Yeah. And then she can also go up here and select print. And notice that we capture the image of the selected chart for you to see, and then you can click on print. And by the way, this is one line of code to do this
in the top component.
In the top component. So that was cool. We were happy about that. Okay, so this finishes up our demo. We wanted to show this demo to you initially because this will give us something to work with. And what we're going to do now is we're going to take you through a roadmap of all the things we did to create a rich client application like this. And then we'll break it up into its pieces and show you what we did. And along the way, we're going to do some simpler little demo programs to get some basic concepts across. And then we'll go back into the SDA, look at the code, and show you how we did all these things. Okay, so what we'll do next now is we want to talk about the NetBeans platform. We want to give everybody an overview of that. And after we do that, we'll talk about how we can construct a basic application from scratch and add JavaFX content to a top component. All right, now for those of you that haven't seen or heard of the NetBeans platform before, I mean, almost everybody knows about the NetBeans IDE, which, by the way, is written with the NetBeans platform APIs. But the NetBeans platform APIs are a very, very extensive set of a system that's really, we think, worth learning. It's a Swing-based rich client framework, all written with Swing components, where the UI components are implemented with the Swing toolkit. And then there's a runtime container that gives you a minimal set of modules that manage the modular architecture and the plugins that the NetBeans platform provides. There's also a window system, very sophisticated, with a window manager. You saw that when Gail was moving the windows around after she undocked them, and we were able to resize them and everything else. And modules that make up the modular architecture of the NetBeans platform is a key concept here, because a module is really an encapsulated set of classes in Java packages. And one of the big things about the NetBeans platform are its plugins, okay, a plugin can consist of more than one module, but modules can be added at runtime, and the APIs that come with NetBeans platform, there's an extensive set of those that are all modules that you can use in your system. And the NetBeans platform also provides a way to register and look up services and capabilities. Now, why would you want to use it? Well, I hope that our demo got your interest on that, because if someone didn't know that we were using the NetBeans platform, they would think that we were pretty impressive GUI programmers, right? I think it goes without saying that the NetBeans platform is modular and extendable, has a very sophisticated window manager. We already mentioned an extensive set of APIs. But it has more than that. It has a service infrastructure and the ability to hook into lifestyle management. So you can actually control a lot of what happens when events occur in the NetBeans platform. And before the platform does something, you can do something before that and after it. And these are lifecycle type things that are very, very granular and let you do a lot of your custom work there. And I think that it goes without saying that what the NetBeans platform does is it reduces development time, because you don't have to worry about all the plumbing that's required for the Windows operations that people expect to work when you're using a desktop app. The NetBeans platform is also platform independent. And don't forget, there's a real active community that's going on with the NetBeans platform, and that's a good thing. And then Gurtan Wailenga, do you want to stand up here, Gurtan, so everybody can see you? Yeah. He didn't stand up very tall, but there he is, yeah. Gurtan runs a blog that he blogs daily on the NetBeans. He's the evangelist for the NetBeans platform. And feel free to talk to Gurtan, after our talk or whatever, to find out more about how you can learn about the NetBeans platform, because there's training courses and a lot of really cool things that you can do to get up to speed in it. Okay, as far as the architecture goes, we mentioned the fact that we have a very sophisticated modular architecture here, a collection of related classes where one module can expose its public interfaces, and then one or more modules can set up dependencies to these. And we're going to show you how that works when we go through the wizards that come up. And you'll see that the whole design behind the NetBeans platform is it's loosely coupled, and because of that, it makes it very easy to install and uninstall plugins and configure the system at runtime. The distribution for the NetBeans platform gives you all of these things. It's quite extensive, and you have everything from Windows systems and lookup and file system. You have APIs for nodes, property sheets and Explorer, dialogues, actions, UI utilities. It's a lot to learn, but there's a lot there too, and a lot of it will really help you out in terms of putting together a sophisticated application with this platform. Okay, the runtime container, let's talk a little bit more about that. The runtime container in the NetBeans platform's job is to load modules dynamically as they are needed, and it has the ability to unload, install, uninstall modules at runtime. And it also has bootstrap capabilities, startup modules, file system APIs, lookup, and utility APIs. So it's there to help you, and it's going to take care of a lot of the runtime issues that you don't have to worry about. And the NetBeans platform also has a family of class loaders that you can use. The module class loader will load most of the classes that you need, and then there's a system one that will load resources outside of the modules that you have in your system, and then of course, has accessible to the original, the default class loader, which you can always use to load resources out of your class path. Let's talk a little bit more about modules. The concept of dependencies is very, very big in the NetBeans platform. This is a contract between two modules where the first module declares that it explicitly exposes its package, and then another module sets a dependency on that and says that I need to access those packages to do something to work in tandem with that other module. This is not unlike working with interfaces in Java, right? Where you implement an interface, you override a method, and then you're implementing a contract at that point. But very often, the client that is using that contract doesn't have any idea what's going on behind the scenes because it's decoupled. Another big concept with the NetBeans platform is this lookup capability. This allows you to set up communication between modules, and you have global lookup to look up implementations directly, and you have an instance content to look up notifications when needed. One more time, here's a little diagram we put together just to show you, and we're going to demonstrate this in a few minutes here, about how dependencies are set up in the NetBeans platform. Once again, this is a contract between two modules, so if module B is going to depend on module A, then module A will declare its packages public, and you do that through a wizard, and then module B will set a dependency on module A, and you'll do that through a wizard. And there's no accidental dependencies that happen here. It's a very clear arrangement where you set that up, and that enforces the correct dependencies, and again makes the loose coupling, which is what really makes NetBeans platform so nice. We mentioned top components. Let's tell you a little bit more detail about what a top component is. A top component extends JComponent, so that means it's part of Swing. It's the basic unit of display, and it's integrated into the Windows system of the NetBeans platform. And you can configure your top components to be singletons or non-singletons if you want to. And of course, top components have built-in code that will allow you to dock and undock, minimize and maximize, and even slide. And you can set it up so that you can open up a top component at startup or not. You can have it persist so that if you close an application, your application, and bring it back up, the windows will persist across the close and come back up into the state they were in. And there's a rich set of annotations that you'll see with top components that really let you configure them any way you want. Okay, so we went over the overview. Now what I think you'll find interesting, the first thing we want to do is we want to show you actually how to build a NetBeans platform application, very simple one from scratch. Okay? And we're going to go through these 6 steps right now, where when we're all done, we're going to have a NetBeans Platform application with a top component that has JavaFX content in it. So what we're going to do now is leave the notes, go back to NetBeans, and we're going to go through these 6 steps.
So first I'm gonna.
Okay, we ready?
Yep.
All right, so we're going to start from scratch. Gail's cleared out everything in NetBeans, and we're going to go through these 6 steps now and show you how to build a NetBeans Platform application with JavaFX content. Okay, step number 1 will be to create a NetBeans Platform application. So Gail will go up to the File top menu here and select New Project, and this will bring up a wizard that you see where she'll select the NetBeans modules and then select NetBeans Platform application. And then she'll name it, and we'll name it Demo App, right? And the location is already preset, so she can click on Finish. Now what happens here is that we have a skeletal NetBeans application now with no modules, but it's ready to be configured with more modules, and that's the next thing that we're going to do. Actually, the next thing we want to do, though, in step 2, is we want to add the JavaFX runtime library, because this NetBeans application is going to require that. So here's the deal. Applications that contain JavaFX have to include a special jar file that is in the JDK distribution, and the name of this is jfxrt.jar. So what we're going to do is we're going to have to add this jar file to this NetBeans application as what we call a wrapped library. Now, a wrapped library is a library that is converted to a NetBeans Platform module, so the jar file can be integrated into the runtime container of the NetBeans Platform. Okay, so let's create this wrapped library now with the JavaFX runtime. So what Gail's going to do is right-click on Modules and then select Add New Library. This will bring up a wizard, and then Gail will browse. You browse to your JDK distribution as we're showing there. And there it is, right there. That's the JFX RT runtime.jar that has to be wrapped and added to this project. So we'll go ahead and do that. We'll select it. And then we'll go through and give it a name. So you're going to call this JavaFX runtime. And then we'll accept the rest of the defaults, click Next. And then the last thing we have to do is put in a code base name. And Gail's going to put in JFX RT, same name as it is for the jar file. And now we can click Finish. Now when the wizard completes, what you'll see on the left over there in the project view is a new module under the Modules folder. And this, of course, is called JavaFX Runtime. That's the name that Gail gave it. So let's right-click that and go down to Properties and select API Versioning. And what you can see down here that Gail can scroll through here is a list of public packages. And what we're going to do is scroll down to the one that we created.
No.
Oh.
We didn't create anything.
Yeah, we haven't done that yet. That's right. So these packages are available, right? So we'll just tell you about that right now, and then we're going to create it and then show you how to access that. Okay, so let's close this window and go to step 3. Okay, now step 3 is to create a new module. And we'll do that because this module is going to hold the JavaFX content. So in our demo application, let's right-click on Modules and select Add New. And when NetBeans will bring up the new module wizard. So Gail's going to put in a name, and we're going to call it Demo Module. And the project location and folder defaults are fine, so we'll click Next. And again, we have to specify a code base name and a unique one. So we'll put in org.demo.demo-module. And we'll keep the rest of the defaults and click Finish. And now, over in the project view, you'll now see 2 modules out there on an application that correspond to what we're building here. All right, now remember, we talked about how important dependencies were when you have these public packages exposed. So step 4 now is going to be to add a module dependency, and we'll do that in the following way. So we'll expand the demo module project and right-click on Libraries and select Add Module Dependency. Okay? And here you see a dialog that contains all the modules in this application. Now we can scroll down and find there it is, the JavaFX Runtime. That's the module that we created. So we'll make this accessible, right? And when we click OK, if we expand the Libraries node now over in the project view, you'll see the JavaFX Runtime module appear. And there it is. Okay, step 5. There are only 6 steps here, right? We're on step 5 now. The next thing we need to do is create a window, and this is called a top component. So let's add a window to our application now, and we'll go to Demo Module, and under Source Packages, we'll right-click, select New, and then Window. There we go. And now we're in the New Window wizard, and here you get to specify how you want to configure your window. So the first thing that we'll do is we'll click on the window position and make it editor, which is going to basically put it in the middle. And then there's a whole list of checkboxes here that you can select that will configure your window. And we'll just click the first one, Open on Application Start. And what this does is it generates, as you'll see in a minute, a bunch of annotations that then will configure the window and install it into the system. The remaining options there were just limiting the Windows behavior, and we'll leave all those unselected. Okay, so now we just have to put in a class name prefix. So Gail's going to type in demo, and this will appear in the names of all of our Java class files. So you'll see the word demo prepended there. And now we're ready to click Finish, and bingo, we have a top component. Notice it shows up in the design view on the right. There's the name demo top component there. And if we compiled and ran this right now, it wouldn't be very interesting. It would be a blank window. So what we want to do now that's going to be interesting is we're going to put JavaFX content in here, and we can do that because we have the wrapped library there that we can use. So that'll be the 6th step now, is to add JavaFX content.
Talk about the libraries that added to support window operations.
Yeah, I will. Okay, so let's click on the source button now and take a look at what we have. Remember, NetBeans generated this top component for us. So one of the things that you see here are annotations down below that correspond to the choices that we made when we went through the wizard. And part of what you see in there was editor in line 23 right there. That's the one we specified with the checkbox. Open at startup equals true. And this is all generated for you by the NetBeans Platform wizards, but these annotations will configure the window, and then you can do what you want with it. Okay, now down in line 36 is the constructor for the demo top component. And right now, it's not going to do anything except set a tooltip. So what we're going to do is replace this now with some JavaFX code. So Gail has a window open at this point she's going to go to now. And this is some JavaFX code. So what we're going to do is we're going to copy this and paste it into our constructor code here. She's doing that now. So here it comes. And we're going to get red lines, right? Because these classes and things are not haven't been imported. So let's fix that first. Let's right-click and say Fix Imports. And we have to be a little bit careful here. Because when you do this in the NetBeans platform and you're using JavaFX, don't just click OK. Take a close look and make sure that you're getting all the correct imports. As Gail scrolls down here, you'll see that when she gets to the rectangle, that's not the right one. We don't want the AWT rectangle. If she clicks on the arrow there, you'll see that the one we want is the one in the JavaFX scene there. So that's the right one we want. And now we can click on the OK. The rest of them are fine, and now all the red lines will go away. Now don't worry about this JavaFX code right now. Basically all we're doing here, as you can see, is in create scene is we're creating a stack pane. We create a drop shadow effect. Then we create a rectangle, and then down below we set up a text component and we just put in a little hello greeting message there, hello from JavaFX. And then the rest of this code is going to set it all up. But notice that this JavaFX code is inside of the top component and it's inside the NetBeans Platform application. Okay, let's go ahead and build this. And we'll have, there's the splash screen, and there it is. So we have a top component now, and same thing, Gail can maximize it, move it around, float it. That's what top components do, right? And everything rescales itself appropriately, and it's not too exciting, but you know, this is a very simple little hello message in JavaFX with a little drop shadow and so forth. But what we did here was we showed you guys how to go through these 6 steps to create a NetBeans platform application with JavaFX content. Okay, Gail's going to leave. Let's see, Gail's going to go back to the slides now.
In just a minute.
So we'll give her time to do that. And we'll move on to the next subject in the agenda. So next slide. Okay. So we are ready to move now to the next subject, which is JavaFX integration. And so what we want to do now is we want to go through and teach you guys a little bit about what properties and bindings and so forth, so you can see and learn a little bit about how you do these things in JavaFX. And then once you learn that, we'll go into the SDA and we'll see how we did some of these things that you saw in the demo. So let's start with observable lists. This is a very cool thing in JavaFX, the ability to use the observable list interface so that you can use part of the collections from JavaFX. There are special collections that manage observable lists, and what these things do is they add notifications for registered listeners. So if you guys have ever done pub/sub type things, where maybe you implement an interface and override methods to do notifications and registered listeners, you don't have to do any of that. JavaFX has this all built in to the observable list, so when you do these things and you use properties, you have less code to write, and yet pub/sub type things are being implemented for you. Now the reason why you want to use observable lists from JavaFX is because it makes it really easy to synchronize your UI list controls with list data and to synchronize the model with your UI components themselves. And it hides all of the registering of listeners and event notifications that you normally have to do. It hides all that. So that's a good thing. Now, a fundamental concept behind what we're doing in the SDA, which is binding, is to use what's called JavaFX Properties. And JavaFX Properties are very, very similar to Java Bean components, except that they're observable. Okay, which means that there's registered listeners and event handlers that you can attach automatically. And the reason why you want to use properties is because they encapsulate data with event delivery, and they can be used with binding expressions, and all the JavaFX controls provide properties for you that you can use. I always tell people that JavaFX properties are like Java properties on steroids, because instead of having a Java field and then having setters and getters that will configure an object that's referenced by that field, you can use JavaFX properties and have all of that done for you. Now, binding is really the secret behind how we are doing all those fancy things in the SDA. So let's talk a little bit about that now. What's binding? Binding lets you take properties and have them participate in dependencies with other property values. And the reason why we want to do that is because it's a natural fit for UI controls that we can now synchronize with their model data. So if we're doing MVC, which a lot of you know about in terms of doing GUI designs, we have a model and we have the view, and a big part of what we have to do in Swing is we have to make sure that these things are synchronized. And what we can do in JavaFX, it can use binding mechanisms to have that done for us. So what binding gives you in JavaFX is the ability to avoid writing event handlers and listeners It's a lot more concise, and it's less error prone. So bottom line is you want to use binding because it'll simplify your life and it'll make your development tasks a lot easier. Okay, so let's learn, since this is a tutorial now, we're going to teach you a little bit about the binding strategies that are available to you in JavaFX. And here they are. You have 4 choices that you can do, and we're going to demonstrate these for you now. Simple bind, bidirectional bind, a fluent API, a library of APIs that you can use, and then of course custom binding, which is what you would do if none of if you can't use a fluent API or do anything in a simple way. The concepts are that simple binding is updating a property when a property that's dependent on that changes, and this is a one-way change update. So it's just one way. But if you need to have it in both directions, you can set up a bidirectional binding, and that would be a two-way change update. And we'll have some examples of these coming up when you see them in a few minutes. You can also bind properties to compute values using built-in binding expressions, and this is called the Fluent API in JavaFX, and we'll show you some examples of that coming up. And then when you just have to have it your own way because there's no other way to do it, you can specify your own custom binder, and then you have a lot of power here. You can specify property dependencies and arrange to have callbacks to a compute value method where you can do whatever you have to do. Okay, so let's show you some examples of these binding strategies now. And here's our approach. We're going to take a small, different program now, a simple one, where we can teach you these different binding strategies. And then after you learn those, we'll then go into the SDA and show you how we were doing them. Because I think it'll be easier for a lot of you to see that when we do that. Okay, so Gail's going to bring up a different program now. Remember, this program will be available in the downloads, so you can get this program too.
Plain JavaFX program.
And this is just a plain JavaFX project. This is not a NetBeans platform. This is one that we wrote to show you some of the binding strategies. So Gail's expanded the source code now, and then what we'll do is we'll go ahead and run this, and we'll show you what it is. Remember, this is not a NetBeans platform application now. This is just a standalone JavaFX program. Okay, here it is. This little program is designed to teach you how the binding strategies work in JavaFX. At the top, we have a couple sliders. The one on the left is an adjusting a fill color, where you have a label for a color. Underneath it, cadet blue, of course, is what you're seeing right now. The right slider is adjusting the size, and we have a number that appears there with 1 digit to the right of the decimal point. And then down below, which is where we're going to start, we have a button on the left, text field in the middle, and a label on the right. And right now, what Gail's going to do is she's going to go in and type in a different word here. And notice as she types in turtles, the label is updating automatically as soon as she hits a key. This is all being done with binding. So we're going to teach you that first. And then when Gail clicks on the reset word button, both the label and the text field is going to be updated automatically. Again, that's going to be doing binding as well. Okay, so let's go see, let's not do the sliders right now. Let's just go down. Actually, I think we do. Yeah, I think we will show you this slider right here. Now, what does this do? When Gail moves this slider, you'll see the colors change in both the rectangle and the circle down below. And did you notice that the label's changing as well? See how it's going from corn silk here to crimson and cyan. So this is all being done with binding. So as Gail moves the slider, both the fill color that's being used to fill in the colors for the shapes, the circle and the rectangle, is happening, as well as the label that's being shown there. Okay, now let me show you how easy this is if you haven't seen these binding things yet in JavaFX, because it works out pretty well. Yeah, so let's go back to the slides, and we'll show you how this works. And I think this will be easier to see on the slides rather than to go in the code, because some of you folks in the back might not be able to see it as well. Okay, let's start with unidirectional binding. That's the first binding strategy in JavaFX. And what we're going to do is we're going to work with the label that you saw, that had the dolphins word on it. And what we're going to do here is we're going to bind the label text property to a string property. Not a string, but a string property. And a string property is a observable JavaFX type that holds a string, but it's observable. Okay? So here we go. String property word equals new string property dolphins. Okay? It's just like creating a string in Java, except we're using a string property instead. Here it is, one line of code, word label dot text property dot bind word. Now, and that will make it so that when Gail types in something, what happens is when the string property word changes, the word label's text property automatically updates. So think about this as setters and getters being done for you behind the scenes by somebody else.
And event listeners.
And event listeners, right, because there's event listeners that are going on here as well. Let's look at the other example where we had the color fill happening with the circle and the rectangle. In one line of code here, we're saying that let's bind the circle fill property to the rectangle fill property. And what this means is that when the rectangle fill property changes, the circle's fill property will update. And this is a unidirectional notation now, right? So it just goes in one direction, but this explains both of the things that we just showed you here, so that these things will change automatically for you, really in one line of code. Now, the other interesting thing about unidirectional binding is it's not possible for you to assign to any bound properties yourself. For example, you cannot assign a value directly to a word label's text property or a circle's fill property. Okay, because it has to go through the binding mechanism to update that. Let's look at bidirectional binding now. Bidirectional binding looks like this. I'm going to repeat the same two lines that we had before. String property equals new string property dolphins, word label text property bind word. And we already saw that. And what happens once again here is that when word changes, word label updates. What we can do now is a bidirectional bind between the text field, that's what Gail was typing into, and the word itself, which is the same word that you see up above. This is going to be in both directions now for the binding. Okay? So when Gail typed in the word turtles, right, with bidirectional binding, when the text field input changed, as she typed things in, the string property word updated, right? That's what this says. But because the word updated, then this binder kicks in, and that will change the label as well. So you have two things going on here, all with just this simple code where the labels are being updated as the text field is being changed. Now that was in the direction of typing in something in the text field. Remember and recall that Gail clicked on the reset button. When Gail clicked on the reset button, we updated the string property word. So when we updated the word, then the text field input will change. So you saw the text field input go back to dolphins. And then because the word changed once again, the word label will also update. All of this is happening as you saw it with us writing just these simple lines of code. And this is what the power of JavaFX binding. And there's a lot of stuff going on behind the scenes here, right? But we don't have to be writing a lot of that code, and that's the whole point.
Okay, go back to that.
So,
We're going to go back.
yeah, so what we'll do now is we'll go back to the program, and before we get into the other bindings, we want to show you the other slider that we have. So Gail's going to bring back not that one, right? Yeah, you want to bring back the binding demo one. Yeah, there we go. Okay, so once again, we use this example down here and the left scroller up above to demonstrate unidirectional binding and bidirectional binding. Now, to show you the other binding strategies, let's work with the other slider. Now, when Gail moves this slider, two things are going on, three things actually, right? The rectangle and the circle are expanding and contracting. And you can see the number changing automatically as well. And this is all being done by binding with just a few lines of code. Okay? So let's go show you how we do that. So we'll go back to the slides. Okay, here is the code in JavaFX that binds the rectangle height. Let's just talk about the rectangle now. Same thing for the circle, right? But you could see that as Gail moved the slider, the rectangle enlarged and then got smaller, right? Bind the rectangle height property to the slider value times 4. And what we did was we threw the times 4 in there as a scaling factor, right? So it would just grow bigger, and so it wouldn't be really small. We could make it grow bigger like that. Well, it turns out that we can use the Fluent API in JavaFX for this, because there's a multiply method that you can call to multiply the value of a property with some other expression that you have. So basically what this says right here, this one line of code that you see right here, is specifying that when the value property of the size slider changes, we'll update the rectangle's height property with the slider's value times 4 using the Fluent API method called multiply. Okay? And that's where the multiply comes in over there. And of course, if you look this up in the API reference guide, you'll see multiply, add, subtract, divide. So anytime you need to do any kinds of scaling things with properties that you're updating like this, you can use the Fluent API, and it's very convenient. Once again, one line of code there to bind the slider value to changing the height property of the rectangle. And then, of course, it's rendered and everything for you. The other thing that you saw was that the label was changing as well. So when Gail moved the slider, not only was the rectangle getting bigger and bigger, right, but the label was also changing as well. So this is another example of a Fluent API. This one line of code right here takes the size, binds the label text property to the slider value and formats it. Did you notice that you said 1 digit to the right of the decimal point there? So specifically what this bind statement does is that when the value property of the size slider changes, we'll update the label's text property by converting the slider's value to a formatted string. That would be 1 digit to the right of the decimal point. And to do that, we'll call the Fluent API method as string, and we'll give it a formatting, .1f right there, so that that label will be showing up with a number and 1 digit to the right of the decimal point. Again, one line of code to render and change that label as the slider is moving. Okay, now the only one left is the custom one, and this is the one that we're using in that program to modify the color names that you see, because when Gail moved the slider, the color slider, you saw the color names come up, corn blue, corn silk, right? To do that, we wrote a custom binder, and this is the fourth strategy that you have in JavaFX binding. And you use this because, the Fluent API is quite extensive, right? But it can't do everything for you, and very often you'll have objects that have to change, and you'll have to do that yourself. So let's show you how to build and create a custom binding object. And we'll call this custom binding object color name binding, okay? And the idea with our bind down here is the same idea, right? Bind the label text property to color name binding, and that means that when the color name binding object changes, the color label's text property will update. It's the same exact concept as before, except that what we're binding to in the argument here is a custom binding object. So what is this custom binding object? Color name binding is something we made up. It's not in a JavaFX API. So let's go see. Here it is, color name binding. And the first thing that you notice is that its type is string binding. And string binding is a JavaFX type where the color name binding object must be a string binding type, because what a string binding type does is it gives you, when you implement it this way, is it gives you the ability to return back a string type where it's needed. So this is how your custom binder works when you can't use the Fluent APIs or any of the others. What you do is you new your string binding object and you give it the name, color name binding, and then in the constructor you call super.bind to provide the dependency. And in this example, what we're doing is we're saying that when the value property of the color slider changes, then this compute value method will be called. So what we do is you override this method, and that will be a callback now. So once again, when the value property changes in the color slider, when Gail is moving it, we will have this routine, this method right here being called. And then we can do anything in here, right? Okay, so what we're doing here is, we have an array. We won't show you the code, but we have an array of color names in there, right? That's what color names is. It's an array. So you see the square brackets right here. So all we have to do is go out to the color slider's value property and get its value, convert it to an integer, index into the array, and return back a string. And so that is what you saw with this custom binder when Gail was moving the slider and you saw the label change with the color name. Okay, so those are the 4 binding strategies that JavaFX gives you. We used a very simple program here to demonstrate those. So the next thing we're going to do now is go into the STA, right? The big program we showed you here. And we're going to go into the pie chart controller code first. And now when you see some of these binding expressions, they won't look Greek to you. You can see them, they'll look familiar to you because we went through some of these binding strategies. Okay, so Gail's going to go into the pie chart controller code now. And there we go, and make it a little bit bigger. So let's scroll down to about line 90 here. And again, what a lot of you probably want to do is study this code when you get a chance, right? And so I'm going to point out some things to you, and we're not going to have time to go through all of the things here. But in line 91, there is an example of a custom binder where the chart title changes when the title property of the chart changes when you change the chart of the title. So this chart title that you see there inside the bind is a custom binding object. So if Gail scrolls up here a little bit, you will see what we just talked about. In fact, it's string binding, right? So in the constructor for the custom binding object, we call super.bind to get a column, the year. That would be, when Gail selects something from the, for the year in the pie chart. And then because that's bound to the chart property, compute value will be called. And then what we do is we go out and we get the title. We get the title from and the year from the table, and then we create a string and return it back, and that's what you see.
Let me show them
And she's going to show you that right now. See?
This is the title.
See, there's the title. So when she selects 2008, it updates. See? And that's that custom binding object. That's exactly what it's doing right there. Okay? Okay, let's go down, scroll down to line about 212, I think it is. And we'll show you another one. Again, you can look at these on your own. There we go. Remember when the percent label changes when you select a wedge, right? So what we do here in line 212 is we are binding the label's text property to a custom object called percent binding. So let's go up to the percent binding. There it is in line 188, it looks like. And what's interesting in here is that you can call super bind more than once. This is interesting, right? Look at line 188. We have a for loop there where we're going through and binding, all of the wedges, setting up binding dependencies on each one of the pie wedges. So we actually have a for loop there in the constructor that's successfully calling super.bind for each one of the pie wedges. It's an interesting technique. That means that if any of the pie wedges change because of the bind, then the compute value will be called. And then what we do in the compute value, of course, is we calculate the percentage for that wedge, and then we can display that, as you see, up in the label. Again, and a good example of custom binding objects now in the pie chart. Now, we could also go into the bar chart controller, and we could do that, but for time purposes, we're going to move on here. And what we're doing in there was we made up custom binding objects that rotates the label's position. Remember when that came up in the bar there? And so we have custom binding objects that take care of all that too. Okay, so let's go back to the notes and move on to the next subject. Swing and JavaFX, how do you make them work together? What's the plan and what do you need to know? And there's some interesting things to talk about here, so let's do that. Again, we're going to be talking about this now in NetBeans Platform application. Okay, what makes this all work so nicely is a very nice Swing component called JFX Panel. We call this the magic of JFX Panel. This is the package that it lives in, and it allows you to embed JavaFX content into a Swing app. So once again, JavaFX is not all about giving up your Swing code. It's about making, keeping your Swing components there, but adding JavaFX effects. The interesting thing about JFX Panel is as soon as you knew it, as soon as you create an instance of it, it'll start up the JavaFX runtime, which, as we're going to discover, is a thread that you need to know about. So it starts up as soon as you create an instance of JFX Panel, and then any input or focus events are forwarded automatically to the scene graph, so you don't have to worry about those being intercepted by Swing. Here's an example where you create a Swing JFrame, call it My App, then create a JFX panel. Okay? As soon as you do this now, the JavaFX application thread starts up, and then all you have to do is what you normally do in Swing is add the JFX panel to the frame, and you're ready to go. Now, there's more to do with this with top components, but you get the idea. It's all very simple, and that's the way it should be. All right, now let's talk about some of the thread issues, because this is important, and we certainly learned a lot when we wrote this program. Swing components, as you guys all know, are all created and updated on the EDT, the Event Dispatch Thread, and that's well known to Swing developers who work with GUIs, and probably all of you know about that. Here's the interesting thing. When you work in JavaFX components, there is a separate thread, separate from the EDT, and it's called the JavaFX application thread. And you need to, you need to be aware of the fact that there is a separate thread with JavaFX when you have these two working together. And we're going to show you the scenarios, typical scenarios now that you could use to have that happen. So here they are. There's three of them. There are probably more scenarios than these, but these are the three that we'll talk about. And they are the following. The first scenario, JavaFX event updates Swing component. That happens when you need to update a Swing component because an event has happened with JavaFX. The second scenario is the opposite. Okay, Swing event updates something in the JavaFX scene graph. This is because something happened in Swing and we need to update something in JavaFX. And the third scenario is a very advanced one where you have to specify synchronization. And basically this is a special case of the second scenario where timing is involved. And here you have to wait for changes in the JavaFX scene graph to complete. And we actually ran into this when we were implementing saving the file charts. We actually had some timing involved between the two threads, and we're going to show you what we did here to solve that. Okay, so let's learn how each one of these three scenarios would work. Okay, and this one's the simplest one because a lot of you are familiar with this, right? This is the basic idea behind updating Swing data with the EDT, and this is what you would do if a change in JavaFX data required you to update something on the Swing side. So what you do here is that you wrap your code in a runnable object. You call Swing utilities.invoke later, and then you override a run method, and inside the run method, that's where you would change your Swing data. And that would ensure that that would be done on the EDT. And a lot of you are familiar with that because the Swing utilities.invoke later is well known to Swing developers. All right, now here's the new one. This is the JavaFX thread. Okay? This is the opposite of what we just said. A change in Swing data requires you to update JavaFX data. Isn't this exactly what we're doing in the SDA? What happened when Gail went down to the table, the Swing JTable, and updated an entry? Didn't we have to update the JavaFX charts? This is this scenario right here. By the way, the first scenario we don't use in the SDA, but this one we use with all of the charts, right? So notice that this is platform.runLater. It's the same exact concept that we have with the Swing thread, except that this is the Java application thread. Platform.runLater, it's the same approach. You new a runnable, override run, and you change the JavaFX data. So if you go into our code where you see the updates being done for the charts, when a table entry changes in Swing, this is what you'll see. And in fact, we're going to show you that right now. Okay, so we're in the pie chart, right? Yeah, we're back in the pie chart because that's one of the simpler ones to look at here.
There we go.
Yep. Okay, so there we go, down in line 120. It's actually started at line 110. There's the table changed. This is what happens when Gail made a change in the J table, the Swing J table. This was a callback to this routine here, table changed. And so after we go and we gather the data that we need from the table, we then down in line 120 have to update the pie chart. So there's the call to platform.runLater, and we've got a comment in there in JavaFX application thread, update the scene graph in JavaFX, and there is the set pie value, which is going to change the pie chart. That is being done inside of the application, the Java application thread.
And do they want to see the bar chart or not?
And I think we'll skip over the bar chart there. The same thing would happen in the bar chart as well, and you can look that up on your own when you need to. All right, now this one was a tough one, right? This was the special case of the last scenario where we have to synchronize with a JavaFX thread. What happened to us here was you can see that this method is getting an image called buffered image. Remember when we demoed the fact that we could save a chart and we have to go out and get that chart? This is the method that's being called to do that. What's interesting though is that we have to do this. We have to go through the controller and call getImage in the Java application thread. That requires that you call platform.runLater to do that. But here's the deal. The platform.runLater returns immediately. So there's a timing issue because we can't just return the image on the Swing side. We have to wait for the JavaFX application thread to complete before we can return the image. So what we're doing here, and I won't go into all the details, but we're using the Java Concurrency API, a countdown latch. So what we do is we set a countdown latch to 1, and then we go and we go to get the image out in the Java application thread. And down here, if this code gets there before this completes, you see the latch.await. That will suspend at that point, and we will wait until the Java application thread is finished. And the great thing about the countdown latch is you just count it down in a finally block, and then that will make us return from the await, and then we know that the Java application thread finished, and then we can return the image back. So there are thread issues that you have to work with when you're doing bindings and working with JavaFX and Swing together. But we have organized these into some scenarios that are fairly easy to follow. Okay, let's go back to, we're back in the notes here, and we're ready to move on to the next subject, using FXML. So we want to show you guys some things about that too. So let's do that. Now, I don't know how much you know about FXML, but this is an XML language that's used to describe UIs. What we're trying to get away from here with JavaFX is kind of the old way of doing things, which was that you create a component with new, and then you use setters and getters to configure it. And that's all fine and dandy when you build a GUI, but eventually, there's going to be changes that have to be made, and that means that you have to go into the Java code, and you have to find it, and change it, and recompile. The idea behind FXML is that you take what's called a declarative approach to your GUI designs by using XML to specify your layout, and then you separate the layout of your UI from the Java code that controls it. Okay? So this is a classical MVC design approach where we can use annotations for the UI elements, which you'll see in a minute when we look at the code. And then you can use CSS to style, your components, which is also separate from the Java code. And you can use FXML and CSS together Or you can use FXML without CSS, or vice versa. You can use CSS without FXML. But you want to use this because it reduces the Java code, it separates the presentation view from the business logic, and it's a lot easier to visualize the scene graph structure declaratively than it is to go and wade through Java code. The other thing that I want to tell you guys about is that there's also a new tool, relatively new tool that's come out in JavaFX called Scene Builder. And this allows you to do drag and drop so that you can build your GUIs very quickly with palettes, and you can drag and drop components. And the interesting thing about the Scene Builder is it generates FXML. So it would be good for you to learn about that when you can. Okay, let's bring up the pie chart once again here. And we're going to look at two files here. The pie chart FXML file first, and then we'll look at the Java controller code that works with it. So let's bring up the FXML code first. There it is.
Okay, hang on.
Yeah, get rid of that. There you go. There we go. Okay, now we don't have much going on here, right? I mean, it's pretty simple. We have a stack pane, and inside of a stack pane we have a pie chart. We have a list view, right, the drop down for the years, and then we have a label. However, with this kind of declarative layout, you could very easily put together more complicated UIs, and we don't have a complicated UI here, but this is what we have. Now, the things to notice in here are configuration is done by simple assignment statements. Max height equals 60, max width equals 60. We're configuring the list view component here. We're configuring the label down below with a font size, making it bold. These are all styles that we do here. The other thing that you want to look at is that in the tags for like pie chart, you see an ID there, ID equals chart. And then we have one for the label, and we have one for the list view. These correspond to the fields in the Java class that is the object that's controlling that. And the other thing you want to notice in line 14 is the FX controller tag that says that the Java code that works with this XML file is called pie chart controller. So let's have Gail go to that right now, and then you'll see how that works with this FXML file. And we need to go to the top here. There we are. Okay. Now, the first thing you notice is that when you build a controller that's going to work with FXML, you need to implement the initializable interface, okay? And then that will force you to override the initialize method down there in line 65. And then, of course, what you'll want to do is create your component at that point. We're going to call create pie chart. And what you notice now up above that are the FXML annotations. And what's happening is those annotations are causing the FXML file to be read, and then Java Reflection is creating the objects for you and configuring them. All you have to do is annotate those in your Java code, and the actual configuration of those components is not in this Java code. See, it's separated. So obviously, this is a good thing because your Java code is not littered with a lot of configuration stuff for your components. And this is how they work together. Okay, so the next subject that we want to look at in our agenda is setting up JavaFX in top components. Again, top components, of course, in a NetBeans Platform app. So let's take a look at that. Okay, now you remember that we did this a little bit earlier. We talked about JFX panel, the magic of JFX panel. That's the starting point for using JFX with Swing. So when you create a JFX panel object, you have a handle to something that you can use, and also it starts the JavaFX application thread, as we talked about. And what you can do with an FX panel is you can add it to your window, and you can specify a border layout. You can do all the things that you can do in Java Swing. And then, of course, when you want to create the scene, you will want to always do that in the Java application thread. So that's where the platform.runLater shows up. And you've already seen this, right? But there's something else in here that's very important, and that would be what's in the middle, platform.setImplicitExitFalse. This turned out to be very important when we were developing the STA because of the following reason. This call is important because what it does when you call it and you set its argument to false is it keeps the JavaFX runtime alive when the last window with JavaFX content is closed. So what we noticed that before we learned about this was when we didn't do this, when we closed some of a window that had JavaFX content in it and we tried to reopen it, it came up blank. And we didn't know what was going on, so we researched this out and found this. So it's pretty important. So once again, you want to have this set up somewhere in your code when you're using JavaFX and Swing together, because then when you close a top component, or when you close a window that has JavaFX content in it and you want to bring it back, it will keep the JavaFX application thread alive for you. Okay, let's look at Create Scene now on the next slide. And this is just some stuff that's out of the SDA to show you how to load the fxml file as a resource. It also shows you a little bit about how the fxml loader works, how it sets the location and set the root, and then set the scene with the root. And then here is getting an access to the controller. And remember, we talked about the Pie controller, because the Pie Chart controller works with the PieChart.fxml file with the annotations. And this just gives you some code that you'll see in the SDA that sets that all up. Okay, so now we're ready to talk about JavaFX charts. So that's the next thing that we'll do here. And we've got a lot of stuff to show you here. So let's go through some of these things and see what we can tell you about. And once again, since this is a tutorial, we're going to go ahead and show you how we did some of these charts in the SDA. And we'll also learn about using the charts in JavaFX as well. Okay, so to start with, there's a hierarchy in JavaFX that looks like this. And we could have drawn it as a tree, but there's an abstract class called chart at the top. And underneath it, you can have a pie chart or a family of what we call XY charts. Okay? And the pie chart, of course, is separate because it doesn't deal with XY concepts, but all of the other charts that you saw that were running in separate windows in our SDA application are all what we call XY charts. And that would be the bar chart, stack bar chart, area chart, and everything that you see here. Okay? So let's talk about the pie chart. Let's talk about JavaFX charts in general first, okay, and give you some general ideas about what you can do with them here. First of all of the charts use observable lists, okay? So that means that you can use binding and then properties and everything that we showed you earlier in this talk. That also means that you have event handlers for special effects, and you saw some of those special effects that we did, drop shadows and animations and things like that. Now, XY charts have a concept of the data being ordered in a series. Okay? In fact, XY-chart.series is something that you would use on your XY axes for these charts. So in the SDA, remember we had 4 years, right, between 2008 and 2012, and then we had 6 series in each year representing the 6 companies that you saw in the data. The chart data itself is XY-chart.data for the XY charts and pie chart data for pie charts. XY-chart.data holds the data for an individual data point in an XY chart, and pie chart.data holds the data for a pie wedge. Okay? And remember that observable lists will let charts respond easily to changes in the data and redraw their nodes as required. Okay, now when you work with charts, you'll have to work with category access and number access. And category access is what you use that renders labels as strings, and number access will render data as numbers. Some XY charts require a category access for one axis and a number access for the other. So we've got that listed for you when we look at some of the individual charts later on. Other XY charts require number access for both X and Y axes. So you'll have to refer to some of the API reference guides to figure that out. And of course, there's some books out there in JavaFX that tell you this stuff too. Now, to make your charts look nice, you're going to want to configure some settings. So notice that there's APIs to manipulate the label of the axis, its position, lower bound, upper bound, and even down to a granular level where you can do tick marks, tick units, specify gaps, and custom formatters. So there's quite a bit that you can do here, and you can make some of these charts look really nice when you do this. Remember that the visual effects are all there with drop shadows. You can manipulate the opacity and so forth, and it applies to all the charts. All right, let's start with a pie chart and give you a little more detail about how you would create one. And once again, what we're going to do here is a little tutorial, right? We're going to show you how to create a very simple pie chart, not in a NetBeans application, but just in a standalone JavaFX program. And then after we do that, we'll go into the SDA, and then you can recognize what we did in there in a more complicated program. First of all, why is a pie chart useful? Well, it's because it's all about pie slices with colors, right? But the big deal about pie charts, as you know, is they're showing percentages of a whole, okay? And so you can analyze data. Instead of looking at a bunch of numbers in a table, you can look at percentages, and you can learn more about who's a bigger part of the pie or who's a smaller part of the pie. And of course, the pie slices are proportional to the data values, and what the pie chart does is it calculates those percentages for you, so you don't have to do that. All right, now when you work with pie charts in JavaFX, you'll work with piechart.data, which stores the name of your slice and its associated value. And when a pie chart is rendered, it's rendered clockwise by default. Specifically, it starts drawing at 0 degrees, which is 3 o'clock on the clock, and then each successive slice is drawn in a clockwise direction. However, if you don't, that's the default, right? I mean, if you want to draw them in a totally different way, counterclockwise, or start in in a random way or anything like that, there are APIs that will allow you to configure both the starting position and the drawing direction. In the SDA, the company name is the name in the pie chart, and the value is the number of units sold in that year for that company. Okay, let's give you a little example right now. We're not going to actually run this example because it's very simple. It shows you how to set up a pie chart, and at the end of this code, we'll give you a screenshot to show you what it looks like. Again, this is not a NetBeans Platform application. This is a very simple, standalone JavaFX program that just teaches you how to build a pie chart. Okay? First thing you want to do is create an observable list. We'll call it pie data. Notice it's generic, so inside the arrows, we'll put in piechart.data, because that's what the type would be. Again, observable lists can be used with other types of XY charts because it's generic. And then we'll just create an observable array list that's empty. And obviously, the next thing that we want to do is add pie chart data. And we can do that in the following way. And what Gail and I did was, since the Olympics just happened, right, this summer, we just took some medal counts for these 4 countries, the US, China, Russia, and UK, and we just made a pie chart about it. And we have more than that, right, ... But these are the ones that we'll show you in the slide here, okay? All right, so all you have to do is create a piechart.data element. Here's the label and the value. The label is a string and the value is a number, because that's required by a pie chart. And you create the data and then add it to the pie data observable list. So here are the first 4, and there's a few more, but that's all you have to see there. Okay, this is easy. You have to create a pie chart element, so we'll just create it with the constructor, and then we'll populate it with the observable array list called pie data. So now it's populated with all the pie chart data. And then to set the title, we just call a setter with our pie chart object, and we put in a string that says these are the Olympic medals that were in London of this year. And when you compile and run this program, this is what it looks like. You see the legend down below where we actually have 7 countries, right? From the U.S. through Japan, and then we have an others category. And all of that is done for you by the pie chart. It draws a legend for you and specifies the colors. But you can specify what colors you want too. You can see that U.S. starts at 3 o'clock, right? And then it's going to be rendered clockwise, just like we said. And there's the title at the top, Olympic Medals London 2012. So this pie chart has seven wedges. Okay, so now that you've seen how a pie chart can be built in a very simple JavaFX program, let's go now into the STA and point to you in the code where, again, encouraging you guys to take a look at our code when you get a chance, and you'll see a lot of what we just talked about down here. So let's go down to line about 69 or 70. Well, 69 is going to be create the pie chart, right? And so after we set up a stack pane, the first thing we do in the create pie chart is we're going to call get pie chart data in line 72. There it is, right there. And that is going to create the pie chart. So let's go and look at that right now. Okay, so down, let's see. There we go, right there. There it is in line 135. Get pie chart data for a particular column that we have. Now this is the STA now, right? So this is going to have, be different than the program you just saw. And as you look at this code, you'll see that we're doing kind of the same thing. We're building an observable array list, and we are getting values out of the table and adding it to the observable array list. And then we're going through and creating the pie values, right there, and from the table. And the other thing that we're doing in here, as you can see in line 136, we say if PC data equals null, then do this code here, else do the other code. What's happening here is that the first time that this is called, we create the observable array list and populate it with the pie chart.data items. And then successive calls that can happen when you click on a year, right, and you have to change the pie chart, replace, that's what this code does down here that Gail's selecting. Successive calls where you change the year, repopulate, replace the pie chart.data items with the new values from the table.
That's why it animates.
And that's why it animates when you change, because of the binding. And we showed you how to do that. Okay, let's talk about bar charts now. And we're not going to go through all of the charts here in detail, but the pie chart and the bar chart are the ones that are kind of used the most out there. So we thought we'd spend a little bit of time here talking to you about that. First of all, why would you use bar charts? Well, it's a different concept than pie charts. It displays discrete data, and you can see the relative differences between category series. And the nice part about JavaFX is that you have vertical bar charts, and then you have horizontal bar charts. But by the way, bar charts require category access. Remember we said that some of these XY charts did, so we've got that in the notes for you here. And the interesting thing about horizontal bar charts is that because it's horizontal, your eye draws a vertical line down, and so you tend to read it left to right. And so horizontal bar charts are really good for showing people, where relative lengths are and emphasizing who's got, more discrete data than others. Now, generics is used here with these things. So bar chart.series is now generically set up for XY charts, where this is the X and this is the Y. So on the X-axis is going to be a string, that's category axis, and on the Y-axis is going to be a number. And so that's in all these XY charts, that's what you have to specify there. Okay, we're going to do the same thing. We're going to go back to the Olympic medal count program, and we're going to do a bar chart for that. So you can see how that's done. And then once you learn how to do this, then we'll go into the SDA, and you'll be able to recognize what we're doing in there. Okay? Now this is a little more complicated than a pie chart because we have the concept of a series. Okay? So the first thing we'll do, though, is we'll create the bar chart by creating the axis, category axis and number axis. And then we create the bar chart by specifying the generics so that the bar chart's x-axis is a string type and the y-axis is a number type. After we do that, we do the same thing we did in the pie chart. We set the title, Olympic medal count. We set the label of the x-axis to year. We set the label for the y-axis to medal count. Now, XY charts have series. Now, you don't have to have a series in a bar chart, but you often do. And we do have one in this example and also in the SDA. So we're going to create 3 series here. well, we have a series for each country, right? But we're showing you just these here. Once again, it's going to be xychart.series generics, and it's important to get the types the same. So string and number in all of these XY chart series right here have to agree with the bar chart declaration that we showed you on the previous slide. And we have 3 series here, one for US, one for China, and one for Russia that we're going to show in this bar chart. The next thing we have to do is after we create the series, we have to add it to the bar chart. So we're going to call getData with Series 1, Series 2, and Series 3. I'm just going to show Series 1 here. And this is where we actually specify what the XY chart data is. So you'll see that the string is going to be the year. That would be 2008 or 2012. And then the number is going to be the number of metals, the same thing we had in the pie chart. So we're showing you how to do that with Series 1, and the same code would be for Series 2 and Series 3. And once we've created those, the last step is to add the series to the actual bar chart. And so we do that for Series 1, and we do the same thing for Series 2 and Series 3. Okay, so when you compile and run this program, this is what it's going to look like. 2 years, right? 2008, 2012, and 3 series for each one of those years. And this is a vertical bar chart with an Olympic medal count title at the top. And once again, the bar chart is going to render the legend for you down below. You can control the colors too, by the way. The defaults look pretty good, actually, but you have complete control over changing these things if you want to.
CSS.
And you can use CSS to do that, right? Okay, so just like we did with the pie chart now, now that you've learned how to do a bar chart, let's go back into the STA now and show you how we did that. So Gail's going to bring up the bar chart controller code now. And if she goes down to about 74, 75, it's the same thing. We have create bar chart that's being done in the scene graph for our JavaFX. After we go and set the alignment and get the tick units set up down below, then we go down to line 85, and there's the get bar chart data. That's the method that's going to create the bar chart for us, and then we can set that in our chart. So let's scroll down to that, and there it is, get bar chart data. And doesn't it look similar, right? I mean, once you start working with some of these charts, it's not too bad. There's going to be an observable array list, which is going to be that you're creating there it's a static method in the FX collections class. And then we just set up a for loop over the number of rows in our table and the number of columns. And we create a series right here, the new XY chart series. And then we add the series. Then we create the bar chart data in the middle here. And then at the bottom, we add the series to the bar chart. So it's very, very similar to what we did with the Olympic medal count. It's just that you're seeing it now with real data from a table. Okay, so the other thing that we thought we'd talk about here in the time that we have left here, I think we have about 7 minutes left before we can go to Q&A here. We thought we'd show you how we did some of the animations that you saw, right? Where like the labels faded out and the pie wedge moved. So we'll give you some general ideas of how we did that as well, because that's a big part of the SDA and a big part of what JavaFX brings to the table. Okay, so these are transitions. They're all high-level animations where you're changing one or more node properties over time. And when you work with a transition in JavaFX, you specify a specific node and a duration. And then you use interpolator options where your choices are these here. And what linear means is it's the default, and that means that the animation is applied at a constant rate. Ease in and ease out are animations where ease in is where it's slower at the beginning, and ease out is where it's slower at the end. And then if you say ease both, then you can get animations slower on both ends. This is really easy to do, and the rendering is all done for you, and it makes a very nice looking animation for you. The other thing is in the SDA, we have used these all of these transitions, and I mentioned these earlier, the fade, translate, and scale. And there's also a parallel one too. So we'll talk about all of these fairly quickly here so you can see that. So we just want to give you guys a little bit of code here to show you how easy it is in JavaFX to do these kinds of animations. A fade transition allows you to change the opacity property. And opacity of 0 is completely transparent, which means it's not visible, and 1 is completely opaque. So in the example, we make up a fade transition called FT, and we specify that the duration of the fade is going to be 1500 milliseconds, which is 1.5 seconds. And we're going to do the fade transition on a number label, which you saw in the STA. And then we do the ease out on the interpolator, so we just make a call to that. And then we set the opacity value to 0, which means at the end of the fade, it'll be completely transparent. And then to start the animation, you just say play or play from start. That's all you have to do this. JavaFX APIs take care of everything else that you see there. Let's look at the translate. The translate transition is used to translate the X and Y properties. That was used in the bar chart where we saw the labels that were appearing inside the bars. And they were fading in and out too, but that was what we just talked about. And the pie wedges too. So this is what this looks like. It's a translate transition in JavaFX where you set up the duration again for 1.5 milliseconds for a particular node now that you get from somewhere. And then once you have this translate transition, then you can set the increments that you want to do for the translate. And of course, this is what's making the pie wedge move. This is all we had to do to get the pie wedge to move and come back. There's more to it than that, but this was basically all we had to do to set it up. And the speed in which it moves is based on the new X and the new Y. So you set those so that's visually pleasing to the eye, and then you just call play. And there's more code than this because we set it up so that it goes out and then it comes back. And you can set it up to be continuous, or you can do it just out and back once. And total control, it's just all APIs here that you can make to do that. So that's basically how we basically got the translate transition to work. And then the parallel one is very interesting. This is where you can group multiple transitions together and actually have JavaFX do them in parallel. You can do them sequentially, which means that you can actually have animation B follow A and then have C follow B, or you could have all three animations, A, B, and C, all happening at once. Very easy to do that. You just make up a parallel transition object and populate it with what you want to go in parallel, and then play it. JavaFX takes care of all the animations that you see there. Yeah. Okay, at the end of these slides, I'm just going to have Gail go through these really quick here. I'm just going to point these to you. Remember, these slides will all be online for you guys so you can look at them. Why use scatter charts, working with them, and a little bit about some examples there. So this is good, right? Because as you look at these things, they tell you why you want to use them. They tell you what you need to know. For example, a line chart, you can use number axis for both X or Y. And then this is what we do in the STA. And then here's the area chart, why you use it and what you need to know. And then the next one is the horizontal bar chart, very similar to the vertical one, not too much different there. And then the stacked bar chart requires category access. There's a few rules here about that as well. And then the next one is the stacked area chart. And then the last one, I think, is the bubble chart. And the bubble chart has an interesting argument that you can use to control the size of the bubbles. And bubble charts are kind of cool and what you can do with that as well. Okay, so let's go to the last slide. Okay, great. Now, to wrap this up, I'd like to say a few things in summary, about what we tried to do here. Again, I said this at the beginning, I want to reiterate it again. We feel quite strongly that using JavaFX and the NetBeans platform together is really a good way to go. If you want to get a rich client experience on a desktop application, you don't want to be concerned a lot with all the plumbing that you have to do to manage the windows the way that people expect them to be. It's a lot of work to do that. A lot of you guys have probably done that. JavaFX makes swing type-based code look better. And there's a lot of things you can do there. And we showed you that you can have swing and JavaFX working together, right? But the NetBeans platform is also a good piece of the puzzle here for getting to this rich client application kind of where we want to go with that, because the NetBeans platform handles all of the window managing details that you can use. So there's a learning curve to learning of the NetBeans platform, but it's well worth your time. And if you use the NetBeans platform to create the backbone of your desktop application, and then you take your swing components that you're all familiar with, and you put as much JavaFX in there or as little as you want, you're going to have something on the client side that's going to be very easy to work with, very easy to manage, and very easy to enhance. Okay? All right, so here's our email addresses. We'd like to hear from you guys if you have any questions. There's our addresses on Twitter as well. Remember that the source code for both the complete smartphone data app that we talked to you, as long as the other small little standalone JavaFX demos that we showed you, are all going to be available this afternoon on our website, which is asgteach.com. And then you can go out, you'll be able to go out this afternoon and pull in this zip file where you'll be able to get everything you have there and take a look at what we've done. And, there's a lot of good stuff in here to learn about. Okay, so we're looking good on time here. I think that we can wrap this up and we'll take some Q&A if anybody wants to ask any questions. And if not, thanks for coming and we'll see you another time. Thanks a lot. So we don't have any microphones here, do we? For anybody? Okay, but
so yell loudly.
So, and if you don't want to stand, that's okay, but just talk loud.
Over here.
Do you know if there are any plans, instead of wrapping up or making a wrapper for the JavaFX module in the RCP app, do you know if there are plans on incorporating JavaFX in the APIs?
I've heard them talk about that, but I don't know the I don't know the roadmap.
Yeah, Gerton, you want to say something about that?
It's actually already in the JDK and in the JRE. The problem is that it's not on the platform.
It's on the platform.
Yeah, it's actually physically the JavaFX chart in the JRE and in the JDK. But for some reason, it's not on the platform.
Well, isn't that what you're supposed to do? Put it in the platform?
That's right. Okay.
Yeah. Yeah, this afternoon he's going to do that, okay? But no, you're absolutely right, and you're not the first person that's asked about that. So, this is, and this is a good thing because I think that the NetBeans platform folks have figured out that, JavaFX is good for the platform, and JavaFX needs the NetBeans platform too as an infrastructure, right? So, these two things are going to play together, I think, pretty well. Another question here? Yeah.
You were binding. You had the slide there where you were showing the bidirectional binding, and I didn't see why it had to be, one of them had to be bidirectional. I didn't see why you just couldn't have had simple binding for that one set. So I don't know if you can reference the slide.
Yeah. I think you did need bidirectional binding because you can change, because of the reset button, you can change the word that was the model, the string property, and then you can also change it down below in the text field, and you cannot sign directly to a property if it's the target of a bind. So that's why bidirectional binding would be required there. But I can go back.
Yeah, let's bring up the slide so we can show you that. We'll say it again, right? Do you know what slide that is?
I don't see. How do I go to the...
So it's because of the fact that you were having two ways of updating that thing that you
Right.
had bidirectional?
Yes.
Exactly.
Because if you weren't, then that would have just been
Correct.
unidirectional on that.
Right. So if you took away the reset button,
Yep.
but
Wouldn't
we
need it.
wanted to show the fact that you could do it two ways.
Yeah. Now you're absolutely right about that. If we didn't have the reset button, we could have done it with a unidirectional bind. But because you type something in the text field, it changes the word property.
I'm just changing
Yeah.
the word property, yeah. So I couldn't see why you needed to have bidirectional on that actual text field.
Right.
Right.
Okay.
Good question.
Good. Question in the back there? What kind of a chart?
You have to talk to the controls people in the JavaFX platform. I actually don't know, but let's see.
I've been asked that question because I know what Gantt charts are, and of course JavaFX has opened up Pandora's box now with the charts, right? I mean, this is just going to be the start of a whole bunch of great stuff because we've never had charts, open source and free from Swing, right? So yeah, I've been asked about Gantt charts, and I've been asked about some other specific charts too. So I'm sure there's going to be more of them coming, but you should ask the controls team.
Giles.
Jonathan Giles is someone you could talk about on that. Don't tell him we said that though. Okay, anything else? Any other questions?
Do you know any commercial or open source real-world application in JavaFX that I can see?
Oh. I don't know.
My answer to that would be the ensemble, right? The ensemble. Have you gone to the JavaFX page and looked at the ensemble? Okay, it'll blow your mind, right? When you go to the ensemble, you'll actually see all of the effects that can be done in small little windows. And when you'll click on it, it'll demo the effect for you. It'll give you the source code. And that program is exactly what you asked for. It's written in JavaFX, so it's a real-world program that shows you all the amazing things you can do with JavaFX. So I would say that would be a very good example of a real-world JavaFX application there. Mm-hmm. Yes?
Does JavaFX require OpenGL? Does it require a graphics card? Will it run like...
I think it has a software backup, but it does use as much of the hardware as it can.
The 3D, though, the 3D does require hardware support. Because when you go to Ensemble, I clicked on some of those examples and it said you need a 3D chip, and that would be OpenGL would be involved there too. But the system itself doesn't, for the 2D, doesn't require that. Yes?
What's the earliest version of Java you can use with JavaFX?
I would use 2.2 because anything before that, if you want to use it with the NetBeans platform, it doesn't support that set implicit exit false. You have to jerry-rig a dummy application a dummy scene graph that never goes away. And there's a couple of other methods that we used, grabbing the snapshot of the scene graph that it didn't have. So I wouldn't use anything earlier than 2.2. And recommend using the most recent as it comes out.
Okay, anything else? Anybody else? Okay, thanks for coming, you guys, and enjoy the show, and we'll see you around.